So for those of you who don't know me, I'm Beth Gugino. I'm the vegetable extension plant pathologist at Penn State. And I promise you this is the last disease talk for Hershey this year. I promise. So everyone's always like, oh, you're doom and gloom when you present and all this. I don't know if I want to grow vegetables after you talk, but hopefully there was enough positive encouragement at the meeting this year that you're still going to stay in business. So today I'm gonna be talking about soil-borne disease management in high tunnels, and I think you've heard a lot of really good information from previous speakers, and I think there's been a lot of talk about soil management and soil health and cover crops and a lot of the other sessions. So hopefully I'm going to reinforce some of the things that you've learned and that you've heard in some of these other sessions. So to start. We're growing things in high tunnels for a reason. That protected structure gives us a lot of advantages. It gives us advantages in terms of getting to market. It gives us protection from rain. We can control the environment a little bit better, so we're not dealing with a lot of the same diseases that we're dealing with in field situations. But at the same time, there's another whole host of things that we deal with in high tunnels, and a lot of that comes to rotation, maybe lack of rotation, lots of tomatoes that are going in. So I'm going to be talking a lot about what we're dealing with in terms of tomatoes in high tunnels, because there tends to be a little bit of a lack of rotation with them. But they really are good in terms of yield and economic advantage. So hopefully we'll provide some tools that you can minimize or get yourself out of issues that you have in your tunnels. So we're going to talk about recognizing common soil-borne issues in tunnels, and I'm going to enforce again the importance of accuracy and accurate diagnosis and knowing what you have going on in terms of soil issues. Because a lot of our tools, it might be grafting, might be selecting resistant varieties, but if you don't know and don't have an accurate diagnosis, then you might not choose the right thing in terms of management moving forward. So I'm going to emphasize that again. I've emphasized that in a number of my different talks. Preventative management strategies, really like within the field, we want to try to be preventative. We want to prevent these soil-borne pathogens. If you're seeing symptoms, what do you do now? And then, what are some options for the future? And there's some different technologies and some newer products that are coming on the market that might actually be advantageous for us to use in high tunnels in trying to minimize these diseases. So one that we've been seeing, a disease that I feel like is becoming increasingly more common in high tunnels is timber rot. And timber rot is caused by the pathogen Sclerotinia sclerotiorum. It's the same pathogen that causes white mold on snap beans, on soybeans, on cabbage, really wide host range. That host range includes tomatoes. Have any of you been dealing with timber rot in your tomato high tunnels? Yeah, so number of hands, and I definitely heard this year that it just seemed to be much more present. And so with that particular disease, what you're going to see in the tomatoes is your tomato stems are going to kind of turn a light brown. They're going to get these light brown elongated lesions on it. A lot of times there's going to be fuzzy white growth associated with it, and that's the actual fungus that's growing on the plant itself. And then what happens is that white fuzzy mycelium becomes very, very dense. And in that bottom right-hand corner and kind of in the center of that stem, you see that black structure. And that black structure is a sclerotia. And that sclerotia is what allows the pathogen to persist over multiple seasons in the soil. So really if we have timber rot in our high tunnel, we really need to do everything we can to make sure that sclerotia don't develop and those sclerotia don't fall to the soil, because that's how we create a chronic problem with this particular disease. And these are just some more pictures of what it looks like. So what happens is those lesions, those tan lesions, that fungus is decomposing that plant tissue. And in that process, it's responding and saying, okay, I need to produce something so that I can survive. And so that's where you get the production of those sclerotia. So in this picture, those sclerotia are actually on the inside of the stem of the plant. And you can also then see that white sporulation on it as well. Like I said, it has a really wide host range, over 400 different plant species. And so that's our cash crops, that's our weeds, that's our cover crops. All can be different hosts for this particular pathogen. Definitely a problem in protected culture. The severity is highly dependent on the weather conditions. And so the weather is what determines whether or not those sclerotia germinate and produce the spores that then start the disease cycle. And at the bottom of the slide there, I have a whole bunch of different hosts. So sunflower is an awesome host for sclerotinia. In fact, when I was at Cornell and we were trying to increase sclerotinia in the field, we would grow sunflower. It's an amazing host. I've said soybean, cucurbits. So this is a first. In fact, Tanner sent me this picture this summer. He's like, Beth, I think that there's sclerotinia on cucumber in a high tunnel. And I was like, what? I've never really seen that before. And he sent the picture, and spot on. That's exactly what you're seeing there on high tunnel cucumber is what it looks like on tomato. So again, you got that brown lesion as the plant starting to decay, that white fungal growth, and those sclerotia forming. And so those sclerotia actually have a pretty complicated kind of life cycle associated with them, and that life cycle is associated with the weather. It's not associated at all with what crop you have in the ground. So when the conditions are favorable for those sclerotia, they're going to germinate. And when they germinate, they're going to form what we call apothecia. That's in the upper left-hand corner. Those apothecia are very much like a little mushroom structure that you can see, and then from that mushroom structure, spores will be released, and those spores then can be carried, several hundred feet, maybe even several thousand feet. And what they'll do is they'll need to land on senescing tissue. They need the nutrients from senescing tissue to infect the plant. And so when you think about, this happens to be a cycle with snap bean, but think about tomatoes, when those plants are flowering, those petals are only alive for a short period of time. Then they quickly senesce, they quickly fall off. That little bit of flower tissue is enough that if one of those spores lands on it, an infection can start. And so that's typically how that cycle goes. When we think about it in snap beans, those sclerotia will typically germinate at canopy closure. So the snap bean plants will grow enough that canopy will close. It'll create the conditions that are favorable then for those ascospores, those spores to be released. And so those spores could be released in soybeans or in snap beans in a field near you, and that could be what comes into the high tunnel and starts timber rot in the high tunnel. A lot of people ask where did it come from? Why am I all of a sudden seeing this in my high tunnel? And so then that's kind of that cycle. And those sclerotia, you could imagine, they're kind of like if they're melanized like your fingernail, so they're pretty hard structures that can persist for quite a bit of time. But it's only the ones that are in the very top millimeters of the soil that will experience the environmental conditions that'll trigger them to germinate. If they're buried further deep in the soil profile, they'll tend to stay dormant there, and it's not till you bring them up to the surface that they'll germinate. Here's a couple of pictures of white mold in the landscape. So I said really wide host range. Pumpkin is a host for this particular disease. If you look in this field, the pumpkins that you're seeing the field has actually already been harvested of all of the healthy fruit. They went through and harvested the healthy fruit. What you're seeing are all the fruit that have sclerotinia associated with them. And so if you would look closely at each of those fruit, at the stem end, what you're going to see is a water soaking, and you're actually going to see a white fungal growth that's associated with that. So in the future, this is a tremendous source of spores and of the pathogen that could potentially go into high tunnels. And here's I think it's a soybean. There's a soybean field, same type of deal. It's got white mold, so it could be a neighboring farm that's growing soybeans that has this issue. those sclerotia are germinating, and those spores then are landing in going in our high tunnels, because we have our sides up on our high tunnels, right, to maximize airflow. So management, there's no silver bullet. I'm still waiting for a disease that I can tell you, here's the silver bullet. I have yet to find one for you. I promise I'll try. Preventing excess moisture is really important, trying to keep dry the barrier from the soil in the high tunnel up to those lower leaves, kind of making sure that area is dry, making sure you have good air circulation is important. There is a biocontrol product that's available that will help work and help degrade those sclerotia, and the product is called Contans. It's actually a mycoparasite, so it's a fungus that infects a fungus, and so it will use those sclerotia as a food source. And so that's kind of what you see there in the picture on the right, where the black structures are actually the mycoparasite that are then feeding on the sclerotinia that are developing there on that particular stem. Not a silver bullet by any means, but it's something that could be used around the high tunnel. It could be used as crops are decomposing to help kind of colonize and reduce those population of sclerotia. Not inexpensive. I think it runs about $500 an acre, which isn't great. Yeah, I know, collective moan. But it is kind of effective. Sanitation. So then that leaves us with sanitation. Sanitation is really important with this disease. So, for those of you who raised your hand and said that you had sclerotinia in your high tunnel, what did you do with those plants? In the case of the cucumber, that plant was still producing fruit, so that grower wanted to still continue to harvest fruit from that plant. So what do you do? And well, the best thing to do is to rogue those plants out. You don't want those sclerotia to form. You don't want them to fall to the soil. And when you do that, you want to maybe have a bag there, have something depending on how many plants you're taking out. You need to be really careful to get all of that crop residue out. And again, you don't want those sclerotia to fall to the soil. Sometimes people will say to even excavate the soil that's right around the base of the plant. Again, trying to be preventative. If these get established in a high tunnel, they're there for the long haul, and you're trying to manage them for the long haul. So sanitation is really really important. So I guess it depends on how risk adverse you are as to how quickly you remove those plants from the high tunnel. So that's what I think I had on. That's what I had on timber rot. Does anyone have any questions on timber rot?
Does oxidate do anything for it?
No. The question was, does oxidate do anything for it? No. I think the timing, it doesn't produce spores the same way we think about other diseases like leaf mold or something like that. So, oxidate's only going to kill what it comes in contact with at that moment of contact. And the spores, they're not a large number of spores with this disease the way you see with some other ones. So I think the likelihood of using that product and actually getting it where it needs to be is less. So the next one I just want to talk about is fusarium wilts. I talked about this in the collapsing cucurbits talk yesterday. So there is a fusarium wilt that's associated with tomatoes. So again, they're very, very host specific. Like many wilts, this kind of a general symptom. You get some yellowing. You get collapsing of the plant. You also get vascular discoloration, which you can see there in the lower right hand picture. That's one of the things that we look for when we're trying to diagnose it. Fusariums, and distinguishing it from verticillium in the lab, we actually have to kind of plate it out to figure out what we're dealing with. To make sure, because of host resistance and because of grafting, we want to know if we're dealing with fusarium wilt or if we're dealing with verticillium. We're starting to see more fusarium because of the lack of crop rotation with tomatoes, and so it's not something that all of a sudden will wipe everything out. It's something that builds slowly over time. Here's just another picture of what it looks like. There's multiple races, and so when we think about host resistance, we have to think about picking out resistance to various races. If you look in our production guide, our 2018 production guide, there is a table for tomatoes. Oh, Tanner, that one didn't advance. There is a table in our production guide for tomatoes, and we do list disease resistance. And when you look down that list, you're actually going to see V's and F's associated with it, and those V's and F's our fusarium and verticillium resistance. And so if we feel like you're having issues with fusarium, one thing we want to definitely know is what cultivars are you growing, in terms of are they resistant or are they not resistant. That would definitely be a first step in management. Verticillium would be the other wilt disease that we're dealing with. Again, I think they're kind of hard to distinguish from a symptomatic standpoint. Verticillium, you tend to get kind of more V-shaped lesions, or lesions that are on half the leaf, or you get wilting and yellowing on half the plant. Tends to be a little bit more common with verticillium, but again, it's something that I would want to actually try to culture out and determine what you're dealing with. Unlike fusarium, verticillium has a really, really wide host range. So I talked about verticillium in cucurbits, in pumpkins and vine crops yesterday. This is that same verticillium that we're thinking about that could be in our high tunnels and in our tomato production. There's also a lot of weed species that are susceptible as well. These both fusarium and verticillium are what we call monocyclic diseases. So they go through one life cycle. They go through one kind of generation in a given season. So it's not something that we tend to see move through a high tunnel. It tends to be plants here or there, and that area might get a little bigger each year, but it doesn't tend to just run down the row. There might be some other issues that are going on if it's running down the row. So verticillium produces microsclerotia. They're like poppy seeds, unlike the timber rot, which was a much larger sclerotia. It's the population of those poppy seeds in the soil that's going to determine the amount of damage and loss that you have as a result of this disease. So again, it's trying to minimize that population from increasing in the soil. And there you can actually see in that lower right-hand picture all those little black dots on that. It's a small section of plant tissue that you're looking at there under a microscope. And each one of those black dots is a sclerotia from verticillium in that picture. So host resistance, I know earlier in this session this morning, Caitlin gave a presentation on grafting. Grafting is a great way to deal with verticillium and fusarium in high tunnel situations. I think the economics probably work out a little bit better. I know Art's going to be talking about economics next, but I mean those grafted plants cost quite a bit more than an ungrafted plant. But if you think about the value in a high tunnel situation and dealing with these soil-borne diseases, and maybe you're in a situation where rotation isn't an option for you economically, and so you want to do something like tomato after tomato after tomato, it might make more sense to go the grafted route. But when you go that grafted route, this is where, again, diagnostics is really important, because different rootstocks have different properties associated with them. And so if you're dealing with verticillium, you want a rootstock that's going to manage verticillium or fusarium, etc. Make sense? So that's where you really want to make sure you know what you're dealing with when you're trying to use grafting to manage a disease. Now, you may use grafting for other reasons, for vigor reasons, things like that. But if you're using it for pathogens, you got to know what you're dealing with. Did I emphasize that enough? So we have the Plant Disease Clinic on campus. I know a lot of you are familiar with it. Great resource if you're in Pennsylvania. I know other states in the Mid-Atlantic also have disease clinics that you can send samples for diagnosis. And so we want to work with you to make sure that you know what you're dealing with. So there'll be a form and all that good stuff, but again, use that. So if you're having issues during the season, use it. Don't try to contact me in the winter without a sample and say, I had this issue. Now what do I do about it? Because we don't know what it was. So, we'll keep going. Pythium root rot is a problem in high tunnels. A lot of times it's patchy, like low spots. High tunnels aren't perfectly level. Low spots, if it's not graded right on the outside of a high tunnel and you have moisture actually draining in, and I have seen that in cases where moisture is draining into that high tunnel and accumulating, and then you have tremendous issues with Pythium. Pythium's in the soil, it's everywhere. We're fighting it all the time with damping off and things like that. We can fight it in a high tunnel as well if we're not managing our irrigation well, if there's really low spots, things like that. Pythium is just kind of a general, it's a generalist pathogen. Water management is really, really important. So again, making sure that water is running away from the high tunnel. promoting just general root health. So if you have a nice healthy root system, Pythium is a root nibbler type of pathogen. It'll feed on those fine feeder roots. If you have a nice vigorous root system, so like even a grafted root system, you have that nice vigorous root system. Pythium is going to feed on those roots, but it's not going to really cause a lot of damage that's going to necessarily lead to any kind of economic loss. So things that you can do to promote overall root health are important. I know a lot of people are using trichoderma-based types of products in potting media and in transplant production. That will help go a long way in terms of managing Pythium. The bigger story then is also managing soil health within the high tunnel. And I know there's been a lot of, again, discussions about soil health at this meeting, and even the previous panel speakers talked about the benefits of adding organic matter in terms of trying to improve soil health. That can only do you good in terms of managing these different diseases. And we'll talk about that a little bit more in a minute. So some of the best management practices: crop rotation. Crop rotation's really good to help minimize it. I know, again, we're not all in that position of being able to have the nice crop rotation, but you also need to think about what's going on around outside that high tunnel. That high tunnel is being influenced by the environment outside of it. So when we're talking about managing weeds in the high tunnel, we're also talking about managing weeds around that high tunnel and in neighboring fields, because you're not in a greenhouse that's fully secured. So a lot of different things can get into that high tunnel from the sides. Maximizing air movement, we all know that's good. Mulches are good. Anything to prevent, soil, kind of keep the soil off of the plants, vice versa. We're not dealing with rain splash the same way we are in the field. But say you do have some sclerotia that are there in the soil because you had some issues with timber rot. If you have a barrier there between the soil and the plant, that'll kind of help reduce if those sclerotia would germinate, would create conditions that might not be so great for those sclerotia in that situation. And then roguing and sanitation are obviously, none of us want our high tunnels to look like that one there on the bottom right. I promise that's not a high tunnel from anywhere in this geographic region. It's none, because none of yours look like that, right? They're all nice and clean. So, yeah, right. So, what happens? What if you're in a situation where you have a significant issues? One way is to move to a raised bed system, or move to some type of container system, right? So you're not even using that field soil in that high tunnel anymore. You're cutting that out of the equation. So you're putting down some type of landscape fabric and using bagged culture on the top. Bagged culture on the top still could have issues with things like Pythium. Pythium, can be a problem in different types of potting mixes. Raised bed system, kind of like what Dave was talking about, where then you have a better chance of augmenting that soil. You're kind of putting those roots that aren't in the field soil anymore. You're creating a different situation for it. So there are growers that I've worked with that have had to move to this type of system because the wilt situations got so bad in their high tunnels from lack of rotation. So, but obviously there's a cost that comes with that. There's also things like improving the soil health, like thinking about cover crops. I don't know, how many of you are using cover crops in high tunnels at all? So a number of you. What types of crops are you using?
I put
Hairy vetch? Radish? Mustards? Ryegrass? Yeah? Do you feel like you're able to increase your organic matter using that? Is anyone using it as a biofumigant specifically, the mustards and stuff?
Mustard, yeah,
for nematodes. Yeah? Yeah, mustards are great for reducing nematodes for sure. So there's a lot.
What about a material called biodefense, which is a pelletized mustard?
Oh, so but the question was, what about biodefense, which is a pelletized mustard, so that you're kind of bypassing that step of having to produce and grow the crop. I mean, I know that some people have used it. I've never seen any data associated with it, but I would assume if you incorporate it and you wet it, and then it volatilizes, I assume that you would maybe get the same effect as a biofumigant. Yeah.
I've used it. It's very effective.
Yeah. Mm-hmm. Yep. So it's a way of bypassing kind of the challenges of actually having to try to grow that crop, in that high tunnel. Because when we're growing cover crops, or especially biofumigant crops, we have to really treat them like a cash crop. So.
The down soil, you cannot raise the monsters even, and then you have that much more down soil the next year.
Right, right. So some additional ideas are soil steaming. Oh, getting tongue-tied. Soil steaming, so basically you're pasteurizing, you're not sterilizing the soil. And I know that there's a couple of operations in Lancaster that have the ability to go around to different high tunnels and actually steam the soil. It's an old process, old technology, and very, very effective in terms of reducing these soil-borne pathogens. It's really just a matter of access to be able to do it. But it is effective if you can gain access. Is anyone soil steaming in here? Yeah. So yeah, few. Hey Steve, a few hands. So another kind of future tool, something to think about, is the concept of biological or anaerobic soil disinfestation. So if you were in, I don't know what the session was yesterday afternoon, but there was a session yesterday afternoon where Francisco de Goya gave a great talk on anaerobic soil disinfestation, and this is something that he's worked on a lot in Florida, and I think could be really amenable to using it in our high tunnel systems. And so the idea, let me just get these. I didn't realize I animated it. It's basically a 3-step process, which he talked about yesterday. The idea of providing, identifying an organic source. So this is something that's heavy in sugars that would feed that microbial population in the soil very, very quickly. So you put that nutrient source down, and then you add water to saturation, and then you cover it with plastic. And then in that process, the microbes will actually feed on all of that sugar and will actually cause that bed to become anaerobic. And that anaerobic process then reduces those pathogen populations. And then you can come back in later and plant. And these are some pictures. This is obviously not Pennsylvania. Pennsylvania situation. This actually might even be Florida because of how precisely those beds look outside. But again, it's this process, this anaerobic process. You get the production of all kinds of toxic metabolites and things like that. You're changing the pH, you're changing the oxygen level. All of these different things then contribute to a reduction in the pathogen population. So I think this is something that Francisco's been working with, that I think we could probably pretty easily bring to Pennsylvania to help us in these particular situations. The last thing I just want to share in terms of future tools, there's a new product that's in the pipeline from Marone. It's a Noble, and this is kind of falls along the lines of the pelletized fumigant type of thing. So it's a product, it's a biofumigant that you'll be able to put down with the bed, and when you put it down with the bed, you incorporate it. All of those different things, you get the same type of effect. Again, easier to use these types of products in a high tunnel situation than actually trying to grow a biofumigant crop. And so this is something that's still pending. It's not registered here in the U.S. It's a product that actually is grown. You're growing it on grain. So that lower left-hand picture is the fungus that's actually growing on the grain. So working to then formulate that in a way that it can be applied. So there are some new and upcoming things that we can be using because high tunnels are incredibly popular. We get a lot of really good produce out of them, but we always have to be thinking about how we're going to be managing these soil-borne pathogens. So. With that kind of concludes my talk. I just want to let you know about resources that we have. Our Penn State Extension website has a tremendous amount of resources there. If you go to the forage and food crops page, we have vegetables there that you can sign up for our newsletters, sign up to get additional information. I have a 1-800-IPM hotline that I leave a 3-minute message on once a week during the summer to provide updates to growers who might not have internet access. I also occasionally attempt to tweet. I keep saying this. I attempt to tweet. I'm not a very good tweeter. Tweeter. Not a very good tweeter, but I do try to, at least when significant disease outbreaks occur, to use that also as a form of getting things out. So, But yeah, so if you go to the vegetable site, then you can click on that Get Connected, and that'll allow you to get connected to things that we're doing. So with that, I'm actually right on time, so I don't know if we have
Questions?
time for a question or two quickly. Yep.
It's not on the topic you've been talking on. But did you ever hear of Rise Antonia web light? Is that something?
Yeah. So the question was, have I ever heard of Rhizoctonia web blight? And I have. It's basically Rhizoctonia in the soil can actually cause a foliar disease, typically with snap beans.
The tomato plants had them, and it looked like an army of spiders went down through the top of them and filled it with web.
Huh.
Really weird situation.
That's interesting. Yeah. No, I've never seen something quite like that before.
What I thought it was after I looked it up.
Might be insects though too.
Spider mites.
Spider mites, severe spider mites can cause webbing and stuff in.
Like all down the whole thing.
Interesting.
Anybody else?
One
Any
more
other
question?
questions? Okay, thank you very much, Beth.